Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iwan Syabir Zaman. Matrix number 2023-851774. I'm going to presenting my CSC508 assignment 2. Alright, so now I will explain about the queue and step for my assignment 2. Alright, so for queue, we shall have a first in, first out, which is mean for the first item will be enter will be the first one, and when another item is put, it's gonna be followed by the first one. So for the first item that we insert is gonna be the first one that will be deleted if you want to delete the data. So let's see. So let's say we have a four place for queue. So we have a front here and a back. So let's see how this first in and first out works. Alright, let's say we enqueue a apple. So enqueue is used for queue to insert a data. So the apple will be the front of the queue. Next we enter enqueue orange. So next orange will be behind apple. The apple will still be in the front, just like a queue in real life. Okay, so next we will enqueue mango. So mango will be behind orange. So let's say we dequeue. So dequeue doesn't take any argument and will delete the first data from the queue. So right now apple is deleted. So we have orange and mango. So orange and mango will go to the front. So let's say we dequeue again, and then orange is gone, and we also have mango only. So mango will go to the front. So let me explain about this step. So let's say we have a step for apple, and then we want to add data to the step. Let's say we want to push orange to the apple. So right now apple orange. So right now orange is at the top of apple, just like step in real life. So if you want to remove the data or item from the step, we'll be removing from the last item that we added to the step. So in this case, the orange is the last item added to the step, so we're gonna remove it from the step. So that's all for the explanation of queue and step. Right now I'm gonna explain about my program. So here we have a queue class, which is extended from the linked list. Then we have enqueue, which is to insert a back. Then we have dequeue, which is to remove from front. Then we have a get front, which is to get the first data from the queue. And we have a get end, and it's empty, which is to see if the queue is empty or not. And then we have a print function. Next, let's see stack, which is also the extents of linked list. So we have a void push, which is to insert at front of our stack, and then we have public object pop to remove from front. So pop doesn't take any argument. It's the same for pick, which is we want to see the first of our stack, and then this is the same for queue, which is empty to see if the stack is empty or not. And then we have a print function also. And then for the fruit class, which is the object for our main class, so later I will show you. We have a default constructor, which is food. Then we have a get name and get price for us to print out our food data and to get the price of the food. We also have a toStrings function. Okay, so let's move on to the main function. Okay, so here we have the main function here. Okay, so this is the main function that runs the entire program. Here's what it does. It initializes to stack, food stack and backup stack, and to queue and mini queue and backup queue. So for the first one, user first enter food item and their price, which are pushed into the food stack. Then we copy the food item from the stack to the queue for menu viewing. Menu is displayed with 11 options, which are handled using a switch statement in the loop. So here is the menu. So we use the switch case function for the menu, which is easier to handle. Okay, so for the first one, so here is the first one. In this option, the user is prompted to enter a food name and price. New food is object is created and added to the stack using food stack dot push. This simulates adding new item to inventory using a last in and first out default structure. Right, then next we have case 2. Case 2, this option remove a specific food item by name. It pops item from food stack one by one and compares them. If the item is found, it's removed. The remaining item are pushed into a temporary stack and then restored back. This maintains the original order except for the deleted item. So next we see for the case 3. So case 3 is to display all food. This displays the content of food stack, which is the current inventory, menu queue, which is menu item in FIFO order. And then we have backup stack and backup queue. This is to show the transferring data from queue to queue and stack to stack. Then let's see case 4. So case 4 we have copy stack to queue. Here we clear the queue and refill it with the item from the stack. We've used food stack get first and get next to go through the stack. Each item is enqueued to the menu using queue, using menu queue and enqueue. So next we have case 5. This option calculate the statistic about the food, which is sum, average, mean, and max. So it traverses the queue to sum all price and counts item. It also keeps track of the minimum and maximum price and corresponding food name. Finally, it display the item sum, average, and mean max detail. Next, we have case 6, which is to search food by name. This option allows the user to search food for item by name in the stack. It goes through each item using food stack, get first and get next. If a match is found, it displays the name and price. See case 7. Right. So case 7 is to copy queue to stack. This would the opposite of case 4. It clears the stack and pushes all items from the queue. This may be useful to reverse the order of queue into a default structure. Then we have case 8, which is to backup queue. This create a backup of the current menu queue by copying its item to backup queue. So this just to show queue to queue transferring data. So this is the same for case 9, which is from stack to another stack. So next we have case 10, infits to postfits. This option allows users to input mathematically expression in ifits format. Like for example, a plus b multiply in bracket c minus d. The program convert it to postfit using a stack. Let me explain the function that handle this. Alright, so this is basically the class for this is the function for the infit to postfit. So this function uses stack to convert ifit expression into postfit notation. Here's how it works. It loops through each character of the infit expression. If the character is a number or letter, it adds it to the postfit string. If it's an opening bracket, it pushes it into the stack. If it's a closing bracket, it pops operator until it finds the mesh. If it's an operator like plus, minus, multiply, or divide, it compares precedence and pop lower or equal operator from the stack from fetching the current one. At the end, it pops all remaining operator and adds them to the postfit result. So we have a helper function is operator char. This function to check if the character is valid operator. For example, plus, minus, multiply, or divide. Helper function precedence is assign priority value to operator. Multiply and divide have higher precedence value 2, while plus and minus have lower precedence value 1. This is used to decide the order of operation during the postfit conversion. Okay, now let's see the output for the program. So let me launch the program. So for the first one, it's gonna prompt us to enter name. So let's see, we enter chicken, then our price is 2 ringgit 20 cent. Yes. Fish is 1 ringgit 20 cent. Yes. And finally we'll put meat at 5 ringgit 10 cent. So no. Right, so let's display all the food. So here is the food stack and menu queue, which show all the food that we just entered just now. So let's enter food, say apple and 1 ringgit. Alright, so let's display again. Right, so right now food stack have apple at the top of the stack or at the front, but queue doesn't have apple yet. So we can use the 4 option to copy stack to queue. So 4. Right, so we display again. So right now food stack and mini queue both have apple in it. So let's say we want to delete food. Right, so we delete apple, then we try to display again. Okay, right now food stack doesn't have apple anymore, since it removed the apple, and mini queue still have the apple in it. Alright, so let's use the 7 function. Right, so since we want to copy queue to stack, so 7 display again. Alright, so here again, right, so apple back into the stack. So let's calculate sum average min max. Okay, so this is the total sum of all our food, average price, minimum price, which is apple, and the highest is meat, 5 ringgit 10 cent. Alright, so let's since our backup stack and backup queue is still empty, let's copy from menu queue and food stack to backup queue and backup stack. So 8 and then 9. Okay, let's display. Right, so right now all of food and stack and queue already have data in it. So let's see the infinite expression. Okay. So let's put an example like a plus b multiply in bracket c minus d. So let's see. So for the first postfit, it's gonna be abc, open bracket, multiply plus d and minus. So we put 11 to exit. Alright, so that's all from me. Thank you for watching.